All right, so we are looking at a new section today. This is 4.3 trigonometric functions on the unit circle. Ooh, we actually won't get to see the unit circle until probably a future video, maybe the next video, hopefully. But yeah, we're gonna look at how we get the unit circle first. Okay, and the objective is that you'll be able to find values of trigonometric functions for any angle. All right, so here we have trigonometric functions of any angle. Okay, so here we're using an angle whose vertex is on the origin. Okay, so it's in standard position. And then what we're going to be doing is we're going to be using these formulas. Sine theta equals y over r. Well, how did you get y over r? The reason why is because theta is right there. So you have opposite. Sorry, that's not your theta. You have opposite the y over the r, the hypotenuse. So opposite over hypotenuse. Remember, SOHCAHTOA. And cosine is the x, which is adjacent. So you're imagining that the theta is there. Okay, and we'll look at what that theta is later. Um, and yeah. Okay, so just remember SOHCAHTOA. SOHCAHTOA. All right. All right. So here, um, and yeah, so sine of theta is y over r, so opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Cosecant is going to be hypotenuse over opposite. Remember, it's the reciprocal of the sine. And secant is the reciprocal of the cosine. So hypotenuse over adjacent, r over x. And then cotangent is x over y. So one way to memorize that is, hmm, Tiny? I don't know. Tiny? Yeah, you just gotta remember that. Just remember, one way I remember is like, we're gonna learn that sine of theta is gonna be y and cosine of theta is gonna be x when we look at the unit circle. Okay, so just remember it's alphabetical. C comes before S, just like X comes before Y. So that's how you know what's on top. That's how I memorize. Okay. Somebody's warming up popcorn. It smells good. Mmm. Smells good. All right. Okay, now it's burning. All right, so here's an example. And here it says a given point lies on the terminal side of an angle theta in the standard position. Find the values of the 6 trigonometric functions of theta. So yeah, let's try one of these. Yeah, if you want, you could try 5. I'll do number 8. Okay, so it'll be similar. All right. So here, our coordinates -1, comma 2. So it's going to be in the third coordinate. Remember, the coordinates are 1, 2, 3, and 4. It's probably a long time since you saw that, right? So just remember that's the third coordinate. We'll we'll see that again later. That's -1, comma -2. But then when you look at that, if you draw a line there, right? Here's our theta. If you draw a line there, then here, this is going to be our y. That's -1, and this is going to be our x. And you can think of the theta right there. Drew it really small, I'm sorry. Okay, but we have to find the hypotenuse. Hey, so here this is uh, how to find r. Okay, r is going to be your hypotenuse. So number 8, first find r. Remember, remember the Pythagorean theorem, a squared plus b squared equals c squared. Cha-cha-cha. All right. But here we don't have a, we have y, we have x, and then we have r. Okay, so it's going to be r squared equals y squared plus x squared, or x squared plus y squared, doesn't matter. But we don't want to solve for r squared, we want to solve for r, so we take the square root of both sides. And we get square root of x squared plus y squared. So here, you just want to plug that in. R equals, our x is -1, our y is -2. So -1 squared plus -2 squared. We get r equals -1 squared is 1. -2 squared is 4. Remember, whenever you square a negative number, it becomes positive because a negative times a negative is a positive every single time. So you never get a negative after squaring, unless it's outside the parentheses, okay? So here our r is square root of 5. All right, yours is going to become, yeah, you're going to have a fraction as well. You're going to have a radical as well. So don't worry. Okay, so our r is square root of 5. So now let's plug those in. So sine of theta first, remember, it's going to be y over r. So in this case, it's going to be -2 over square root of 5. And we don't like to have a radical in the denominator, so multiply the top and the bottom by square root of 5, and we get -2 times the square root of 5 over, when we square square a radical times a radical, cancels out. Square root times the square root cancels itself out. You get 5. Okay. When it's the same, sorry, then it cancels each other out. That's why we multiply it by itself. And that's it. That's sine. Now cosine theta is x over r. We're going to have -1 over square root of 5. Same thing. Multiply the top and the bottom by square root of 5. Square root of 5. And we get -1 times the square root of 5 is negative square root of 5 over Square root of 5 times square root of 5 is square root of 25. Square root of 25 is 5. That's how we cancel that out. There you go. Hey! And then tangent of theta is y over x. All right, so our y is -2, our x is -1. Negative divided by negative is a positive, and 2 divided by 1 is 2, so it's +2. And reciprocals. Remember the sign, and then the reciprocal is going to start with an C. C, reciprocal is going to start with an S. Okay, that's how you can remember. So cosecant is going to be r over y. So square root of 5 over -2, and that's it. That's all we can do. For secant of theta, we have y over x, sorry, r over x. And that's going to give us square root of 5 over -1. And we don't really want to have a 1 in the denominator. You can, but you can simplify that. Make it look nicer. So it becomes negative square root of 5. All right, and the cotangent of theta is, instead of y over x, it's x over y. So we have -1 over -2. Negative divided by negative is a positive, so +1/2. And that's it. Yay! Okay, so try number 5. And then this is actually the start of doing the unit circle. Okay, so the unit circle is where our radius, our r is 1. Okay, so it's going to be a simplified version of this, kind of. All right, before we look at that, we're going to look at these. These are called quadrantal angles. Quadrantal, quad, remember, is 4. Rantal, yeah, I have no idea. All right. So we have those 4 sections, right? In a graph. Okay, this is 0 though. This is 0. So the quadrantal angles are going to be here. That's 90, or pi over 2. This one over here is 180, or pi. And this one over here is 270, or 3 pi over 2. And then going back to the 0, you can say 0, or it could also be 360 degrees, or 2 pi. Okay. But we won't really talk about that. We're just going to focus on these 3 right here. 90, 180, and 270. So when we have a when we have a point on the 90, okay, that means it's going to be 0, because the x is 0, and then whatever height that is, r. So 0, comma, r. If you have a point on the 180 on the x-axis, the left side of the x-axis, that's going to be negative r, comma, 0. And if you have a point on the bottom half of the y-axis, that's going to be 0, because you don't go right or left any, and then down r, so negative r. Okay, so Yeah, quadrantal angles. Quad 4. Rantal sounds like Randall. I don't know. All right, so let's try some of these. 14 and 16. Let's do one that's in radians. The other one is in degrees. So why don't you do 9 and 11? I'll do 14 and 16. So 14, you want secant of 180. So if you want, you can draw the picture. Okay, it's easier. And then here, secant of 180. So 180, 0, 90, 180 is over here. That's going to be, all right, so this is going to be negative 1, comma 0. And if that's the case, secant 180 degrees is going to give us, remember secant is uh, r over x. So we have to find the r. R equals the square root of negative 1 squared plus 0 squared. So if r equals square root of negative 1 plus 0, so r equals square root of 1, which is just 1. We have 1 over negative 1. That's it. And we get negative 1. Ta-da! That's it. And 16. So negative pi over 2. So negative, remember, we're going to be going counterclock. We're going to go clockwise. So pi over 2 is up here, but if we go the other way, the negative pi over 2 is going to be down here. So this is going to be 0, comma, negative 1. And r is the square root of 0 squared plus negative 1 squared. R equals square root of 0 plus 1. R equals square root of 1, which is just 1. So we get secant of negative pi over 2, another secant, equals, and then secant is r over x again. So we have 1 over x is 0, so that is undefined, because we can have a 0 in the denominator. Undefined. All right, so there is a presentation, so we are going to end here, and that's it.